Okay, so today we're going to be dealing with trig equations, but we're going to be working them backwards. So we've been graphing them so far. Now we're going to work them backwards where we have the graph and we're going to find the equation. Okay, so starting off with a very, very basic example. Okay, but I want you to see the steps. So just like we did before when we had the equation and then we'd actually create all of this information from the equation, the center line, the amplitude, the period, and the shift. Now we're going to use it and do it the other way, where we have the graph of the function, okay, and we're going to find all this information and then plug it into our equation. So again, if you want to, I would suggest you could write down the parent function where it's going to be f of x equals k plus a cosine of bx minus h. Okay, so that you know where we're going to be plugging all these values in. Okay, so let's start with the center line. Okay, well, my center line is right in the middle. Since my maximum's at 0, 1/2 right here, and my minimum's at pi negative 1/2, that means my center line is here because it's right in the middle of my maximums and minimum. Okay, and that's at 0. So my center line is y equals 0. Okay, and if my center line's at 0, that means k is 0 because it has not been shifted up or down. Because if it had, then my center line would be in a different place. Okay, next let's look at my amplitude. Well, if this is my center line and this right here is my maximum and this right here is my minimum, the amplitude is the distance between your maximums and your minimums to your center line. So this is 1/2, just like from here to here is 1/2. So that's telling me my amplitude is 1/2. So A is my amplitude, so it's 1/2. Okay. All right, let's look at my period. Do I have a change in period? Okay, well, I've definitely got these 2 points. Now, I picked cosine because my y-axis right here, I can see that my graph hits at a maximum, just like cosine does. Okay? And if you graph your parent function, okay, for cosine, so in this case, I'll graph it in a gray so you can kind of tell the difference. 0, 1, pi over 2, 0, pi negative 1, this would be my 0, and then here would be my maximum again. So we can see here that there has been no change in period because my maximum is still at 0 and my minimum is still at pi, just like the parent function. That means my period is still 2 pi. So remember, my equation is period equals 2 pi over b. So in this case, my period is, in fact, 2 pi. So if we had a change, we would have taken this and solved for b. But obviously, the only number b can be to get 2 pi again is 1. Okay? Now, has there been a shift? Have we moved left or right? And since we drew our parent function right there, the answer is no. There has not been any shift, so we don't have to worry about a shift. So there, you can put NA there or just leave it blank. So there's no H. And after that, we just plug in our values. Okay? So we come up here, we have no K. So my f of x, K is 0. My A is 1/2, so it's 1/2 cosine. And this is going to be 1x minus basically 0, or just 1/2 cosine x. And that's our equation. Okay? Now that's our equation if we used cosine, which is the easiest one for this. If we had chosen to use sine, then we would have had a shift, because this function would have kept going and it would have hit here at negative pi over 2. If we had used sine, then our function would have had a shift. Everything else would have been identical. Our amplitude would have been the same. The center line would have been the same. The period is still the same. The only difference is if we were using sine, my function had been shifted pi over 2 to the left. So for sine, it would have been f of x equals 1/2 sine of x plus pi over 2. These two are both the same function. We could have used either one, okay? But I always tell my students to use the acronym KISS, K-I-S-S. Keep it simple, stupid. Okay? Don't sit there and add in a bunch of shifts and a bunch of stuff that you don't need to do if you don't need to do it. If we really had wanted to, we could have said, okay, well then we're going to start sine right here, and it's going to be like this, which means I have a shift to the right pi over 2 and a reflection over the x-axis, and now we're adding in 2 more transformations, and it makes it a whole lot more difficult, okay? So keep it simple. Don't do a bunch of stuff that you don't have to, okay? The reason I use cosine is because right here, just like the parent function, it starts at its maximum at the y-axis, okay? So that's why I chose cosine. All right, let's look at the second example. All right, this one's going to be a little bit more difficult. All right, so let's see. Our maximum is here. Our minimum value is here. Okay? So if my maximum is at 8 and my minimum is at -6, where is my center line? Well, the total distance there, 8 plus 6 is 14. So count 7 down, because that's going to be the midway. So each one of these is 2. So 2, 4, 6, 7. This right here, this is my center line. And that's at 1. Okay. So my center line's at y equals 1, which means k is 1. We just calculated our amplitude. Because I know my maximum's at 8, my minimum's at -6. Remember there was that amplitude equation? A equals max minus min over 2. In this case, it's 8 minus -6 over 2, which is 14 over 2, which is 7. So my amplitude is 7, which means A is 7. Okay? Now let's look at my period. Okay? Well, my function here. Each one of these marks is pi. So this is pi, this is 2 pi, this is 3 pi, this right here is 4 pi. Okay? 5 pi. So let's look at which function we're going to use. Okay? Or you should realize by now that it takes in a normal period to get from its maximum to minimum, it takes 1 pi. For both sine and cosine. Well, from maximum here at pi to its minimum at 3 pi, it takes 2 pi, which means basically my period's been doubled. Or, since we're talking about this, just like before, I decided to use cosine because where it hit the y-axis at its maximum, here I'm going to plan on using sine because the center line, see how this hits on its center line at the y-axis? That means it's easiest to use sine because this right here is going to be one full sine wave. So I don't have any shift going on. But that also shows that my period is 4 pi. So again, before we know that period is 2 pi over b, and in this case it is 4 pi. So we're solving for b, and the easiest way of doing this is setting up a proportion, putting this over 1 and cross multiplying. So 2 pi times 1 divided by 4 pi, so b is 2 pi over 4 pi. Pi divides out with pi, so b is 1/2. So there's my b. Now, since we picked signs specifically that we don't have a shift, do we have a shift? NA, no shift, which means h is 0. So again, come up here. And like I said, if you wanted to put in this is f of x equals k plus a sine of bx minus h. That's my parent function with transformations. And now we just plug things in. So we know k is 1. So this is 1 plus a amplitude is 7 sine. What is b? We found b. That's 1/2 x minus 0. Because h is 0. And there's my equation. And again, if I had decided to use cosine, I had just a weird, crazy idea to use cosine, I would have had to use this cosine wave. Now, everything would have been exactly the same, okay, except for my shift. The only thing that's different between cosine and sine is going to be my shift. And since I do have a shift and a change in period, I would have had to use the phase shift equation to find what h is. So the only added to finding cosine would have been that one part of finding that phase shift. Okay? So since it was a stretch, you would have said, okay, wait a minute. I know phase shift is h over b, and I know it was moved over here to pi, so you would have basically said, oh, I know what b is. So you would have said that this is pi equals h over 1/2, which basically means that to find h, you would have multiplied by the reciprocal, which would have given you 2 pi. Or, yeah. So that would have been the only difference. Okay? But remember, keep it simple. If I don't have to sit there and do a phase shift and deal with a horizontal shift, don't.